Number 5, you have to notice when you're doing these that this changes from a linear inequality to an absolute value inequality. When you do that, you have to remember the properties of absolute values, okay, in the general form. Vertex form of an absolute value is that, we talked about that at the beginning of class, where the HK is the center, and A, the number out in front of absolute value, tells you where it opens, whether it opens up, whether it opens down, and it gives you the slopes in quotes, okay? Kind of gives you how to graph the two different parts of the absolute value. All absolute value graphs are V's, okay? So you need to kind of change your thought process on the way you're going to graph it. It's got to look like a V at the end. Our shading, our conversation on where we shade to represent the solutions, is going to be the same conversation. They're all in Y form, so we're going to decide whether we're going to shade the spots where all the Y coordinates are more than the line or the curve, or all the spots where the Y coordinates are less than the curve, depending on what inequality sign's used. Okay? We have our issue with solid and dashed that we still have to deal with as well. So let's look at this. We have the vertex. Vertex. What's the vertex on this? Somebody say it. 5, positive 5, positive 3. Positive 5 because it's the opposite as to what we think, and the reason is if you look at the vertex form right there and there, it's highlighted. Those are both minuses, okay? Which means this that I'm going to highlight in orange, those both are our H value, which is a positive 5, not a negative 5. Same thing with the K. We have both positive represented in our absolute value inequality and in the equation, so they're both positive 3. So we're going to put a dot at 5, 3. Put a dot at 5, 3, and then we need to determine whether it opens up or down. The A has a negative value, so it opens down, right? And we have slopes of plus or minus 2 we use. So, but we have to make sure it opens down, okay? So we're going to go down 2, right 1, down 2, left 1. That gives us our two different sides of the V, of the absolute value curve. We have to determine whether we're going to use a solid or a dashed line. It's not the equal part. It's less than, not less than or equal to, so it's a dashed line. And now we have a conversation about shading. We don't talk about in or out of the absolute value. We talk about up or down, below or above the curve. The expression that's written is, the inequality that's written is y is less than. That tells us that we want all the ordered pairs where the y coordinate is less than the curve. All the ordered pairs where the y coordinate is less than the curve. That would also mean below in this case. So that's what it would look like. Any questions on that? Okay, let's take a look at the next one. Vertex, -1, -3. Any questions on getting a vertex? That's one of the important pieces of this. One of the things that was a little bit difficult when you were learning it first. Okay, so we plotted -1, -3, and it opens. This one opens up with a slopes of plus or minus 1/3. So it opens up. So I'm going to go up through 1 right 3, up 1 left 3, and it's dashed because we have an inequality that doesn't include the equal part. And our original inequality says y is less than. Okay, so we want all the ordered pairs where the y coordinate is less than the curve. So it's down here. It's below. It's everything down here. Okay? Now on number 7, we're mixing this together. We're doing 2 at once. We're doing 2 at once. Okay, for number 7. Before we get there, does anybody have any questions? Can I clarify it for you guys? Okay, let's look at number 7. Now in number 7, we're actually incorporating, we're doing 2 at the same time because it's a system. A system is more than one thing working together, so we're going to do 2 at the same time. So I'm going to do the first one here. We have a vertex of 1, +1, +4. And we have a slopes of plus or minus 2/3. It's a negative value in front of the absolute value bars. So it's going to open down. So we're going to go down 2, right 3, down 2, left 3. And it's dashed because we do not have the equal part. And we have to look at the sign now. It says less than, y is less than. So we want all the ordered pairs whose y coordinate is less than the curve, which is going to be down. And since this is a system, I'm gonna shade it very lightly, because in the end we really want to figure out where those two shaded regions overlap, and we want to darken in that spot to make sure it's very clear as to where they overlap. So let's do the next one. Vertex again, 1, 1, 1, 1, and we have a slopes of plus or minus 3. That's a number out in front of the absolute value bars. That is a positive number, so it's going to open up. So we're going to go up 3, right 1, up 3, left 1, and it's a solid line. Okay? And if we look at our statement, it's y is greater than, so we want to shade above the curve, all the ordered pairs where the y coordinate is greater than the curve. Now, if you notice where those two overlap, this one overlaps just in that little tiny section in between them. Okay, that's shared between them. That's the section that we want to really highlight, saying this is the spot right there where they overlap. Technically, you can take and erase all this extra stuff because that is not officially part of the solution set. It's just the section that's shared between the two. If they didn't cross, then we would say no solution. But if they do cross, we shade that in really dark and we demonstrate that that's the area. Okay? Why don't you guys, if you haven't already, I want you to do number 8, graph both. We're going to do it. If you did 8 and 9, you were cruising through it, take a look at the back and try to keep working on the back as I do it. I'm going to play one more song. After that song gets played, then we'll come back and talk about it, okay? Peace. And we want to shade up. Okay? Anybody have any questions? Vertex. Absolute value. And Okay, so if they didn't intersect, if the shading didn't intersect at all, we would say there was no solution. Take a look at the back side now. Okay, use your rough program, read through this. Okay, there are two different pieces. We're going to give it two variables. We're going to define two variables. Okay, and those are the things that change in this particular situation. We have to read the wording and we have to identify what the purpose of the problem is, what the whole problem ends up talking about, and the information we can find out in terms of this particular problem. Okay, so read through it and identify the two important parts before you even start breaking it out from inequalities and formulas. Okay, take a second to read through it and figure out the purpose for the wording from the wording. All right, guys, you find out that the purpose, there's two different scenarios in this problem. You're walking, you get paid by walking a dog, and you get paid by washing cars. Okay, and it depends how many hours you work for both of those. Will depend on how much money you make, and how many hours you end up spending. Okay, those are our two variables. X is hours dog walking, and Y is going to be hours car washing. Okay, and those two are going to change. Those two scenarios are going to change. Okay. Now let's write some inequality based off of the wording given in this scenario. This first statement, 20 hours working, is the first number that shows up. That's the total. A lot of times when we're reading stuff, we funnel equations into what represents total, the number that represents total. Okay, 20 hours, 20 total hours, which is going to be made up of the amount of hours you walk dogs to the amount of hours you wash cars. Amount of hours you walk dogs is going to be X. Amount of hours you wash cars is Y, based off of what we've determined. And those two added together need to be 20 and actually less than 20. Because we can get close to 20. Okay? Next piece, we have another total that shows up $90. We also have more information about the amount of dollars you can make based off of those two statements. So those all funnel into the same inequality. The amount of money we want to make is 90, so we want to make either that amount or more. Okay, and the amount of money we make, $90, is made. We make that by washing cars, walking dogs. We get 7.50 for washing dogs, for walking dogs, and we get $6 for washing cars. So take a look at it. You probably make more money walking dogs because there's some hazard walking dogs. So now we want to graph these to determine the solutions that are possible. So to do that, we're going to just make a XY graph. Do we need any other quadrants? Do we need 2, 3, or 4? Or should we just stay in the top right of the XY graph? We get negative hours walking. Won't make sense. So we'll just keep it in this first quadrant. Start at 0. Label your axes if we said X was hours dog walking. And we said Y was hours. Okay. Now we need to determine our scale. Before we do that, it's pretty advantageous to solve these for Y as if you would be graphing them and then determine what you want your graph to go. See if that works for you. Sometimes you might have to change it. I would